Hello, geometry crew. All right, today what we're going to do is we're going to review just some simple problems in section 10.6, which is talking about segment lengths in and around a circle. So I've just got some problems, 6 problems that I've set aside, 2 problems where chords are intersecting inside a circle, 2 problems where we have 2 secants that intersect outside of the circle, and then in the last 2 problems we have a tangent and a secant intersecting outside the circle. All right, so in each one of these it's going to be solve for x, so very basic. Keep in mind that in a lot of other examples we'd have to plug x back in to figure out what is the length of this segment. All right, so in the first case we've got 2 chords intersecting inside a circle. So like we've said in previous classes, the products of the parts of chord 1 are going to equal the products of the parts of chord 2. All right, and I'm just going to highlight this. So the product of the parts of chord 1 would be x minus 3 times 6, and that should equal the product of the parts of chord 2, which is 4 times x. All right, now we could just simplify. So we're going to distribute the 6, so we'd get 6x minus 18 equals 4x. And then from there we could just get our variables on one side, our constants on the other. All right, so subtract 4x from both sides, add 18, we get 2x equals 18, and then finally x equals 9. All right, keep in mind that when we do get these values, sometimes in some certain situations, we're going to get, positives and negatives for x. What we've got to do is we've got to make sure that it makes sense in the context of the problem. All right, so the next one's a prime example of that. All right, so like before, the product of the parts of one chord equals the product of the parts of the other chord. So we have x minus 6 times x plus 3. The products of the parts of that chord should equal the products of the parts of the other chord. So that would be 9 times 10. All right, and then from there, let's do our basic mathematics. So we've got a FOIL. I'm going to show out every step on this one, and then in future examples I won't. Okay, so we multiply the first terms, we get x squared. The outer terms, 3x. The inner terms, negative 6x. And then the last 2 terms, we get negative 18. All right, and that equals 90. Then from there, combine our like terms. So we have x squared minus 3x minus 18 equals 90. Now this is a quadratic. All right. We've got to make sure that we get everything over to one side to solve this quadratic. So let's subtract 90. If we do so, we get negative 108 as that last constant term. Now from here, we got a quadratic that may or may not be factorable. All right, if it's not factorable, we could do things like quadratic formula in order to find our solutions. Okay, in most cases, it's going to be factorable. So let's just try it out. All right, you can use whatever kind of method that you want to use. My preference is guess and check, so that's what I'm going to do. All right, so in order to get x squared, I know that's got to be x times x. And then for the last terms here, all right, I know they have to multiply to be negative 108, but then they've got to add up to be negative 3. All right, in this case, that's negative 12 and positive 9. Now from there, we set each factor equal to 0 and solve. First case, we get x equals 12. Oops, almost skipped a step there. In the second case, we get negative 9. So in the context of the problem, if we look back up, what we've got to decide is, can we plug these values in? So 12, if we plug that in, we'd get 15 here. All right, and for the upper part of that chord, we'd get 6. All right, that works. We can get lengths of that measure. All right, if we plug negative 9 in though, we'd get negative 6 here. that distance can't be -6. All right, so that means -9 will not work, and 12 is our only solution. All right, let's check out example 3. In this case, we have two secants. So this is our secant relationship. All right, like we've said before, exterior times hole equals exterior times hole. All right, and just like the last example, we've got one chord on one side, another chord on the other side. All right, so the first secant that I'm going to pick is the one that's further to the left or farther to the left. So we have exterior, which would be 4, times the whole thing. All right, if we're talking about the whole thing, we've got to add up these distances. X minus 2 plus 4, that would be x plus 2. Now in the next chord, all right, the exterior part's 3. And then once again, the trickiest part is figuring out what is that whole segment length. So we have to add up these lengths. That whole thing is x plus 1 plus 3. So that's how we could get x plus 4, which would be the whole length of that segment. All right, now from here, it looks pretty basic. We distribute, so we get 4x plus 8 equals 3x plus 12. Okay, isolate our variables, so get all the variables over to one side, constants over to the other. So we subtract 3x. Okay, we subtract 8 to get our constants over to the right side. And we get x equals 4. Awesome sauce. Let's check out the next one. Okay, once again, another secant-secant relationship. All right, so we have exterior times hole equals exterior times hole. So I'm going to look at the upper chord first. I should say upper segment. Okay, because that's the secant segment. So exterior times the whole thing, which would be x plus 3. That equals the exterior times the whole thing, which is 10. And now we can just simplify. So if we distribute x, we get x squared plus 3x. 4 times 10 is 40. We want to get everything over to one side, so subtract 40. Now from here, we got a factor. All right now I'm assuming that this is factorable. If it's the case where we can't figure out how it could be factorable, then we'd use quadratic formula. All right, so let's just use some guess and check. So to get x squared, we got to have x times x. Now from here, these last two terms in each one of these binomials has to multiply to be -40 and then add up to be 3. All right, so 8 and -5. Set each factor equal to 0 and solve, and we would get -8 and +5. All right, just a really quick check would determine whether -8 works. -8 can't be this external part, okay, because that distance can't be negative. So we got one solution here, and that's x equals 5. All right, two more. Now we start with our tangent-secant relationship. All right, so for our tangent-secant relationship, we could use tangent squared equals exterior times hole. But keep in mind that we can still use exterior times hole equals exterior times hole. Just for the tangent, right, the exterior part and the whole part is the same thing. So it's a little bit simpler to just do tangent squared equals exterior times hole. Now the whole part of that secant segment is x plus 9. All right, so now we just got to square 15. We get 225. Distribute 9. We'll get 9x plus 81. Now from there, get everything over to one side. So, sorry, not everything. All of our constants over to one side. So subtract 81. If we do that, we get 144. And then divide by 9. That would give us 16. All right, last example. All right, once again, tangent squared equals exterior times hole. The whole length of that segment would be 18. It's really easy just to say 8 times 10 because you see those numbers there. They're right next to each other, so intuitively we just want to put them right next to each other in the equation. Okay, but we got to remember the equation is tangent squared equals exterior times hole. All right, now from here, okay, 8 times 18, that'd be 144. Take the square root, we get positive and negative 12. Now we just got to make sure both of these work. Oop, negative 12 doesn't work. So that means there's one solution, and that's just positive 12. All right, folks, that's it for today. I'll be posting the homework assignment that goes along with this, just a few problems, just reviewing these relationships, those chord relationships in the circle, the secant tangent, and the secant-secant relationships. All right, like always, have a good day.